This is John Black, super chemist. I'm here to talk about how to make aldehydes via hypochlorous acid. Now here's some of the main oxidizers people know of. PCC, pyridium chlorochromate, potassium permanganate, potassium dichromate. Everyone knows these oxidizers. They're strong oxidizers. They're great for making some types of ketones and carboxylic acids. But as for aldehydes, they're not too good. They over-oxidize. They're too good. You know what I mean? When the alcohol turns into the aldehyde, it gets oxidized a second time because it's so strong of an oxidizer. And it turns into a carboxylic acid. Now, why do I say it's good to make ketones sometimes? Because sometimes this stuff is too strong even to make a ketone. Let me give you a couple examples. I got 3 examples here. I got, what is that, 1-phenyl isopropanol, benzyl alcohol, 2-phenyl ethanol. If I oxidize these with these oxidizers up here, you can see they all point to this benzoic acid. All 3 of these things would be oxidized to benzoic acid. Even this one. Why? Why doesn't this turn into, why isn't there 2 carbons? Why does it go all the way down to 1 carbon? This one has 3 carbons. 1, 2, 3. It goes all the way down to 1 carbon. Why does that happen? I could see this one, because it has 1 carbon, this has 1 carbon. Why are these making the same thing? Alright, this is the rule. You can see over here, at the benzyl position, okay, I'm pointing at the benzyl position. That's the carbon that's attached to the ring. That's the benzyl position. If there are any hydrogens on there, even 1, this will happen. You'll have over-oxidation. Everything on the chain, it doesn't matter what's on here, it will all be taken away. And this will be taken down to benzoic acid. Doesn't matter what functional groups, how many double bonds, triple bonds, single bonds, doesn't matter what is on this group. It means none of the functional groups are irrelevant. They're all irrelevant, okay? None of them are relevant. The only thing that's relevant is are there hydrogens here? If there are no hydrogens, then you won't have a problem making a ketone, okay? You won't have a problem with it eating up your whole thingy to make benzoic acid, okay? But if you do have the hydrogen, you're going to have that problem. So even trying to make a ketone, like trying to make P2P here out of this 1-phenyl isopropanol, is not possible with these oxidizers, because you will always oxidize it, over-oxidize it to the benzoic acid. So you need a mild oxidizer. Alright, and here's some more examples. You got ethanol, you oxidize it with those and you get acetic acid. Methanol, you get formic acid. No matter what, you're going to over-oxidize, it will oxidize it to an aldehyde, but it's so strong it'll just keep oxidizing it up to the carboxylic acid. So you need a mild oxidizer. The thing about these mild oxidizers, and I'll just name a couple: chromal chloride, KCC, which is potassium chlorochromate. They have their bad things too. Chromal chloride is so nasty and disgusting, you do not want to work with that, that's for sure. KCC, it's a lot better. It's not nasty, but if you don't have the potassium dichromate or potassium chromate or chromic acid to begin with, you're going to have to make it. And to make it is a long process. So this is out too, unless you've got 10 years to make, your KCC. But there is another oxidizer, hypochlorous acid. So let's look at the examples I have here. Now we're using the oxidizer hypochlorous acid instead of the strong oxidizers. Now your 1-phenyl isopropanol becomes P2P when you oxidize it. Now the benzyl alcohol becomes benzaldehyde. Now the 1-phenyl ethanol becomes, or I mean the 2-phenyl ethanol becomes 2-phenyl acetaldehyde. The ethanol becomes acetaldehyde, and methanol becomes formaldehyde. Now these two, I'm not definitely sure that it works on these ones, but I'm going to try. These definitely work, but I'm not sure. I don't see why they wouldn't, but sometimes these smaller molecules don't work in the same way as other molecules do. So I'm not 100%, but I'm definitely going to do an experiment to see, okay? Now, you might say, well, hypochlorous acid, man, I don't even know how to make hypochlorous acid. Let me tell you, hypochlorous acid is very, very easy to make. All right, so let's go over the mechanism, all right? We got benzyl alcohol, and we have our hypochlorous acid. This is a bad leaving group, and anytime you have alcohol, the first step is usually protonation. The acid protonates the alcohol to make a water group, and these electrons go, so you have an anion, an OCl anion. And over here you can see the water group and the OCl anion. This is positive because you just gave it a proton, right? The oxygen. This is negative because you just gave a proton. So anyways, you're just doing SN2 reaction. This comes in, the negativity, boom, pushes off the water group because it's such a great water group. The water group leaves neutral, leaving this positive, and a positive and a negative makes a neutral. So you have a neutral, this benzyl thing connected to an OCl. Now I drew in the H, right? Because that's going to be the next part of the reaction. Now this, anything in the reaction pot, water, OCl, anything that has some free electrons, can grab that proton, that hydrogen proton, off of there, right? And either make acid or make a hydronium ion. Now when that happens, it leaves the electrons, and the electrons collapse to form this double bond, right? So now you have a double bond with an OCl. But you took a proton off, so this is all negative now, okay? And chloride is actually a good leaving group. So it leaves as a negative chloride anion. And what are you left with? Benzaldehyde. The chlorine anion and the proton can link up to make HCl. And it'll leave the pot. You know what I mean? You have to scrub it out. And that's basically the whole mechanism. The reaction likes to be warm. And notice I didn't say hot. I said warm. Like if you filled up a pot of water and you put your hand in it, would you be like, this is warm, or would you be like, oh man, that's hot? Or would you, it wants to be warm, not cold, not hot. Reaction likes to be a pH of 4. Now this I'm guessing at, and I'll tell you why in a second. I know it doesn't like to be too acidic, like a 1 or a 2, and I know it doesn't like to be neutral. Now, how do you make hypochlorous acid? Well, the easiest way is to use bleach and acetic acid to make that. It's that easy. You can make it in situ. Now let's look at these formulas on how to make hypochlorite. How bleach is made. Bleach is made by you bubble chlorine into sodium hydroxide solution. Water, sodium hydroxide. And what you make is the sodium hypochlorite. That's the salt of hypochlorous acid. You make sodium chloride and you make water. Now this is an equilibrium type thing. You're still going to have chlorine and sodium hydroxide in the mix. And if you push the equilibrium back and forth, if you add acid, it goes one way. If you add, you'll make more chlorine. And if you add a base, it'll go more towards the right over to here, which is what the bleach companies want. They want to make the sodium hypochlorite. So they add in extra sodium hydroxide. So there's a whole bunch of extra sodium hydroxide in bleach, okay? And that's going to come back to bite us later. I'll tell you why. Because you have like making a methyl ketone or methyl alcohol, you know, it'll go through a haloform reaction. But we'll get to that later. So let's say you go out and you buy some cheap bleach, and this is what's in it, right? All this stuff in equilibrium, mostly this stuff, because they push the equilibrium this way, adding so much sodium hydroxide. So, how do you make an acid? You drip a stronger acid on the salt of that acid, right? If I want to make nitric acid, I drip sulfuric acid on potassium nitrate. If I want to make acetic acid, I drip sulfuric acid on sodium acetate. Now here, we don't want to use a strong acid, because what happens when you use a strong acid is you make a lot of chlorine. And also, the reaction likes to be at pH of 4. Okay? And adding hydrochloric acid, I mean, you can do it, but I won't suggest it. I don't like that idea. I like acetic acid. It's not strong, so strong that it's going to release a lot of chlorine. It's not strong enough or it's going to push the equilibrium so far over here that you just flooded with chlorine, right? Because you want the chlorine. The chlorine is what's going to make this HOCl, right? Take the chlorine out, you can't make your oxidizer. So how do we make the hypochlorous acid? We add some acetic acid to the bleach solution, right? A strong acid onto a salt of hypochlorous acid, and we make hypochlorous acid. It's that simple. And sodium acetate. Now, this is a fact. At a pH of 4, like by adding acid to bleach, if you can get the pH to 4, right, then the amount of non-ionized HOCl is the highest. To me, that means, that's why I picked pH of 4. I said the reaction likes to be at a pH of 4. I don't know exactly what it likes to be at, but I know it likes to be somewhere between 2 and, say, 6. I know it, okay? And then I read this in Wikipedia. It says at pH of 4, the highest amount of non-ionized HOCl, which is what we want, is highest. So to me, that looks like a good number that the reaction should be done at, pH of 4. Okay, that's my guess, and this is why. Now let's get into how you actually do the reaction, okay? I'm gonna have to show you 2 ways to do it. One is with the bleach, and one is with hypochlorous acid. The reason why you can't use the bleach is because it has sodium hydroxide in, and that will make it do the haloform reaction. So let's go over the first way, using bleach. Okay, this would be your setup, right? You have a 3-neck flask, you have a thermometer, right? If you want to keep track of the temperature, this likes to be warm, so that means you don't want it to get cold and you don't want to get too hot. So you want to keep track of the temperature. You got a reflux condenser on there, so that when, you know how bleach is, it's not that nasty, but it does have chlorine in it, and it does have stuff that's going to, you don't want it coming out. And then you'd have a adapter here so you can put a hose on it and take your hose to a bubble. Because also, you're going to be making HCl gas, right? Some of it's going to stay in solution, some of it's going to come out there. So you want to scrub that with sodium hydroxide water. Put a suck back, sodium hydroxide water, another suck back, and another sodium hydroxide. You're good to go. Then you have equalizing funnel, okay? And what you're going to do is you're going to put your alcohol that you want oxidized, right, into your flask with the acetic acid, okay? You're going to have vigorous stirring. You have to have vigorous stirring, okay? And then you put your bleach up in the set funnel and you drip it in. The reason why, okay, that way your pH is set. You want your pH to be set at a pH of 4, right? Because that's where all your hypochlorous acid comes from, and that's your oxidizer. Don't miss part 2.